All right, so let's start again. Uh, so I'm going to make a brief introduction to some projects that might can interest you. First of all, I would like to say what we are doing in our laboratory. Here it's written partially in Russian. I will translate for you. Our laboratory is named Biomechatronics and Energy Efficient Robotics Laboratory. We are doing research in, as it can be understood from the name, biomechatronics and energy efficient robotics. Mostly, we have two subdivisions of groups of scientific groups in laboratory. First subdivision is mechanical department. In our small scientific group, we are doing synthesis of mechanisms, synthesis of robots in terms of mechanism and mechanical design. Mostly it touches topology optimization of mechanisms, synthesis of joints and links of robots, and so on. And second department, it's related to artificial intelligence, image recognition, and image processing, and all and so on. And mostly I will cover the first type of topics because I'm mostly mechanical engineer. My colleague Kirill Zharkov, he provided some kind of introduction to some projects, and I also have introduction to mine. So I will start from the beginning. So we are doing automatization processes of designer robotic systems, such as grippers, manipulators, and walking robots. We're making criterions which reflects dynamical characteristics of robots, and we want to find new ways to use artificial intelligence and optimization methods for morphological computation. By morphological computation, I mean making of morphology creation of the robot, such as its links length, joints placement, spring stiffness allocation, and so on. Everything that relates to the mechanical design of robots. So to use not also artificial intelligence, but to use it in terms of embodied intelligence, which means intelligence of the mechanical design itself. One of the tasks we are doing right now, it's for NEOCR. In English, it means scientific and mechanical design work or something like that. We're doing this biped wheeled robot. What's the idea? Uh, it's something like this. It's here you can see quadruped robot with legs. So it's a hybrid locomotion. So we have a legged locomotion which has which can walk over obstacles quite easily, but the speed is quite slow, is quite low. And vice versa, wheeled locomotion has high speeds of locomotion, but it can do this locomotion only on plane surfaces. So to take both good things from both worlds, we are making hybrid locomotion, which means that we have legs with wheels on the toe, which makes us able to ride at high speeds on flat surfaces and also walk over some kind of obstacles which wheels cannot overcome. And here you can see model in Majoka, which you will work with. It's a two-wheeled mechanism. The mechanical design of the leg is a 5-bar linkage with 2 degrees of freedom. Here are 2 motors. And here is the closed chain linkage, which moves the end effector. Here it's the wheel. And here is a Telegram video from Ivan Zharkov. He's embedder in this project. He is up to how to power up all the electronics. And before making the robot itself, firstly, we have made some kind of stand, which looks like a surface where we placed all the electronics of the robot and wants to see how entire electronics talks to its parts, how to power it up, how to control the motors. And here Kirill shows how IMU sensor takes control over the wheels. So it means that if the sensor has some kind of inclination, like of the body of the robot, it starts moving forward or backward like a Segway model. So some kind of balancing construction. But here is all placed on the surface just to look how it works before making the entire design as it's seen on the slide above. So an idea here is for the project consists of three parts. First part is to power up reinforced learning, in short RL, RL regulator for controlling the robot by speed. First is a planar case where you can look only at one wheel, which moves into D plane. B-type a bit harder in three-dimensional world when we have entire robot with two wheels. And the last one is to add control from a keyboard or from gamepad just to control the robot and the simulation model in Majoko. So in short, to power up reinforced learning, put it in Majoko and control robots from keyboards or gamepad. Second type of tasks for this type of work is making your own environment and simulation model of a hybrid locomotion robot. So what you can do, firstly, you can work with springs. You can add spring systems to the mechanism. As previous slide, you can see at the knee of the robot there a rotational spring, which partially compensates the gravity of the robot. And hence, it makes robot spend less energy to support itself in a stable situation when it just stands up. Second is to play with closed chain kinematics. If you know what closed chain kinematics is good, I will not explain it here elaborately. What's this? But you can work with this. Majoko main key thing in Majoko is that it can work with closed chain kinematics because for standard URDF models you can work only with open chain kinematics, but Majoko plays with XML formats which makes you able to make a cell with equation. You can read it Majoko documentation, what's this, and you can make closed chain kinematics. Third thing from the project is to compare different simulator solvers. I will talk about it a bit later. There are three types of solver. Main types of solvers is forward Euler, backward Euler, and Runge-Kutta fourth degree. Ivan Borisov has told you about this in the lectures. I believe you remember it. And last but not least is to add more degrees of freedom for the robot to make it move not only on the plane but in 6 dimensions, to make it rotate in 3 degrees of freedom and move longitudinally in 3 degrees of freedom. And the third type of task is to make a reward function design for jumping over the obstacles. So what does it mean? Here you can see that robot just rides on the surface. But the idea is to use this simulation model to make some kind of control which will make robots able to jump over some obstacles. Because current model just rides on some kind of surface, on flat or over some kind of curvy surface, but doesn't some jumps. For jumping, the robot needs to sit down and release some kind of energy. And to control this, kind of tricky. And if you're interested and have some kind of experience with this, you can play with this thing. So that's about first type of work you can do your project with. Second type of the project is gripping devices. Here you can see a slide which were made by Kirill. He is some kind of team lead of the research group which made a Rostock framework. This is framework which makes generative design of gripping device from these fingers. They grow up some kind of phalanxes with joints which grips objects. And at the left, you can see the graph representation of the grapper device, which is designed by some kind of optimization. As I remember, they use Monte Carlo tree search method, MCTS in short. If you're interested in this, you can read their papers. They have published their article on IRIS recently. And you can write me direct messages if you're interested with this. I can send you the paper and more brief details about this. And potential work you can do with this gripping device, firstly, is to write an adapter for conversion graph grammar rules into Majoka simulation model. What's the key problem here? Guys have made the simulation model, as I remember, in PyBullet or in PyChrona, I do not remember. It's another simulation model in Python, but it's a bit, but it has very bad documentation. It has a lot of lags and some kind of problems which Majoko mostly haven't. And the first key thing is to transfer this simulation model from PyChrona to Majoko. This type of work you can do with. A second type is to make or modify reinforced learning environment for grasping the object from the information from the simulator, which means that you just can introduce some kind of reinforced learning to make grasping device grasp things using Majoka or PyChrona. And last but not least is to make simulation model of the grasping device with under actuation. What does it mean under actuation? Here, the gripping device with these fingers has a lot of phalanxes, as you can see. And actually, to actuate each phalanx, you need to motor at each joint. For example, for this yellow finger, you need to introduce 1, 2, 3, 4 motors. But instead of that, guys have made a different design. They used a wire on, in other words, tendon, which is wired up over entire finger and coils over this high phalanx. And by using only one motor, they manipulate with the entire finger instead of 5 motors. This is the idea of under actuation, which means that you can actuate entire system using a smaller number degree of freedom. Another example on the bottom is a grappling device, which were made by Ivan Borisov, by other Ivan Borisov mechanical design team. They have made the paper on, as I remember, ICRA on 2022. They have made this anthropomorphic gripper, which, as I remember, has only 5 degrees of freedom, so only one motor per one finger. And instead of using 20 degrees of freedom, for example, as for shadow hand, which uses tendon systems, this design uses only 5. So that's the main idea, to use small number of motors. And the idea for the project is to make the simulation model with under actuation. So that's about the second type of work you can project. You can have some motivation and inspiration for your project. Third type of the project is co-design of robot leg with linear drive. What's the idea? For example, for Boston Dynamics Spot robot, this robot use kind of tricky design for the leg. Instead of using just 3 degrees of freedom with 3 motors attached on each part of the leg, for example, one motor of the hip which rolls the leg up and down, one motor which makes hip go up and down, and the third motor put it in the knee to move the lower limb up or down. The mechanical design of the leg is a bit more trickier. It's firstly use the motor as the hip to rotate the leg, but instead of placing these 2 motors with rotation degree of freedom at the bottom, it use all these 2 motors at the upper part of the robot. What's the idea? If you place heavy parts on the body but not on the leg, it decreases the mass of the leg and hence it decreases the inertia of the leg, which means that reflected inertia of the leg while it's moving on the surface becomes lower, and that means that it spends less energy. The lower mass and inertia has the leg, easier to manipulate it with. So here, designers make the following idea. They placed the motor on the upper part of the robot, and instead of using rotation link, they actuated with linear drive. Here is a screw, and here is the nut, which is connected to the lower part of the robot. Here you can see at the bottom the patent sketch of the mechanical design. Here is the motor, pulley, screw, and the nut which moves this link, which makes the leg move up and down. What's the key thing here? Why not rotational link? Why just not placed 4-bar linkage with parallelogram geometry just to move the leg? The idea is lies in back drivability. What's the back drivability? It means that if you move not the motor but the leg, it starts actuating the motor itself. But mechanical system is a bit tricky. Some kind of mechanical designs cannot move backwardly. They cannot be actuated by external force because, for example, some kind of high friction in gears if you use reducer, or some kind of tricky geometry of the linkage. But linear drive makes us able to move backwardly, and its back durability is very good, which can be used, for example, for recuperation of the energy of the motor. For example, when leg lands on some kind of surface, it starts to move the nut and then starts rotating the screw, which starts rotating the motor. Firstly, it makes the leg compliant. It's not it's not infinitely rigid. It's bends over some kind of obstacles. And secondly, it can recuperate some energy when motor rotates and starts generating power. So the idea here is to make this co-design of the leg. What kind of work you can do with? Firstly, is to run a rabbit hopper or over the classical control. Rabbit hopper, as I remember, is the simplest type of hopper which were made by MIT, and it's a pretty simple design. It's just rotating a link with spring, which makes robot jump like inverted pendulum model. Second is to run a rabbit hopper over reinforced learning or so use some kind of hybrid type of control. If you want to work with some kind of control, you can. I think you understand what I mean, because I'm not a specialist in control. Absolutely, I'm just scratching the surface. If you know what to do, you just write more elaborate discussion. And last is to assemble your simulation model of biped or quadruped robot with select locomotion and run on it Loco Majoko. As I understand, it's some kind of library for Majoko, which is made for some kind of locomotion tasks. I think it mostly covers the control sequence. Better to read by yourself because I do not know what's this, because that was proposed by my colleague who knows what was this. So, and the last type of project you can work with was proposed by me is generative design of compliant joints from tessellations. What's the idea? What's compliant joint? It's some thing which deflects, or in other word, bends. Uh, and you can do this elastic deformation not as a, not you most mechanical designs try to overcome the elastic deformation because they say it's bad, but key thing here is to use this for better because elastic deformation allows the robots uh, how to say this, to work as a passive spring, as a passive accumulator of potential mechanical energy, to store this potential energy to ease the motion of some kind of like robots, or to make the design compliant inherently, because the entire design just bends. It's very bendy, it's very elastic, and it's very animal-like. And here is the idea is to use the tessellation. What the tessellation is? I think it's better to show it on the some kind of simulation model. I have the the design here. I have used specific CAD tool. It's named Rhino Grasshopper. Rhino is a CAD design tool, and Grasshopper is its library. It looks like this. It's a graphical programming thing. You can program the entire design which shown on the right. And here you can see this alien-looking construction. And you can play with these parameters. You can, for example, change the geometry size. You can change number of these bubbles. This tessellation is named Voronoi tessellation or Voronoi lattice. It makes these small dots. Let me show. It's briefly what does it mean. Firstly, I create the rectangle. Secondly, I create the population, random population of dots, and then create this kind of complicated tessellation named Voronoi tessellation. So let me show the last result. And also, you can play with tessellation by using some kind of density. You can make attractors. Attractors means that you can place some kind of geometry, for example, this curve, and make in the region of this curve another addition of points and create Voronoi lattice, whereas inside this curve will be a lot more dense. Let me show it better, just to say. I will introduce a curvature here, and voila. It makes this density, which makes the entire construction a lot more dense in the center. And if we use this lattice for compliant joints to make elastic deformation of this thing in a perpendicular way, this dense part will increase the stiffness of the compliant joint. And the idea is to of playing with the geometry of this lattice, differ compliance of this bendy thing. So, for example, here I can play with number of points of this attractor. So it's becomes looking very alien-like, and I think that's cool. I think that's look very very interesting. So that's the idea of the project, to use lattices for compliant joints. And here you can see how made from some kind of random curve. And at the right, you can see 3D printed designs, which I made when I was trying to use this CAD design tool for making these lattices. And key parts of this project. First is to write API which connects this CAD Rhino Grasshopper and Python, because we cannot right now control in time design of the CAD in Rhino by Python. We just use these pictograms from the using visual programming language like LabVIEW for Lego Mindstorms. Maybe if you know, you know. And idea is to write API which connects these two worlds, CAD design tool and programming language. Here it's Python. Second is to create a mesh model from generated compliant elastic some kind of thing to import it into Majoko, because Majoko can work with elastic bodies. It can simulate deformations. And last but not least is to make the simulation model of the leg with this some kind of Paralympics bendy thing. And you can use this as the end effector on the end of the 4-bar linkage or 5-bar linkage. Here is the Asken 2 Pro design. It's 4-bar linkage, which is driven only by one motor. And at the end, instead of this rigid link, you can place this a compliant thing and can play with this. That's the entire idea for this project. If you're interested and have some issues or questions about this, you can answer me, or you can ask me, of course, not answer. You can ask me and I will answer you. So next I will go to the first practice tasks and discuss entire thing of the subject. But before that, I would like to hear from you some questions about this presentation if you have them. Maybe you want to discuss some kind of projects more elaborately, or do not understood something, or have some additional questions about this.
I have a question.
Yeah.
We can suggest a project from our imagination, not just these projects, right?
Yeah, of course. That's just motivational examples of what kind of things you can do, and the degree of complexity what you need to what your project need to have, like as a presentation. If you have different idea and don't like something from the presentation, you can do idea from yourself. And then also, I want to add that you can do your project in a small group, about 2 to 3 people. Maximum is 4, but better to have a group from 2 to 3 people. And I believe that working in a small group makes you divide some kind of tasks to work to perform a better result of the project. So if you're interested in another topic, you can imagine it by yourself.
Okay, thank you. So
Mm-hmm.
I'm not saying that they are not interesting, but I'm more interested in like computer vision stuff. So can we
Uh-huh.
go this way, or we're just
Of course. Yeah, of course. I will talk about the system, how to approve your project a bit later. But yes, of course, you can work with this, and you need to implement some kind of simulation model in Majok from this chosen topic.
hmm Thank you.
Mm-hmm. So, other questions?
Yeah, what is B2 robotics lab?
Uh-huh. You want what?
Yeah, what is B2 robotics lab? I don't know
What's
about.
this? Ah, you
Yeah,
asked.
yeah.
It in short means biomechatronics and energy efficient lab. That's a laboratory we are working in. It's placed in ITMO University on Grivtsova Street. And we are doing all the stuff I have shown you in this presentation. It's some kind of topics we are doing in our mechanical design research team. So we're making mechanical design of the robots.
So can we work there as well?
To do what?
Can we work there?
You want to, could you repeat, please? I didn't understand.
Can we work there? I mean, in order to work on our project.
You're asking, can you work on another kind of project?
No. Can we work there in that lab?
You're asking, can you work in this lab?
Mhm.
Yeah, I got your point. There are some kind of open pl working places, and if you want to work, you need to prove that you're how to say it. The leader of our lab is Sergey Alexeyevich Kolybin. He's the head of our lab, and he makes the final decision. And to for his decision to be positive, you need to approve some kind of test task, which is being given by him or by my scientific advisor Ivan Borisov, who is the head of the subject. And as me, I went to this lab I was from different university, and I just asked Ivan, can I work in your lab? And he sent me a test task. I have made it somehow, showed him the results, and he made his decision, and he approved that I can work it. So if you want to work, you need to ask, I think, Ivan Borisov, and he will cover all the and he will answer all your questions, because here I'm not up to this stuff, because I'm just assistant PhD student, not the professor. So
Good, good.
ask me in a direct message in Telegram about this a bit later after the lesson, and I will send you Ivan Borisov's a mail where you can ask this question, and he will help you with this.
Okay.
Mhm. Other question, guys?
Meeting. If we have a question, we should ask who? We should ask, depends on our subject, or we have, for example, one person that all the time text him or something.
There are some troubles with the connection. You're asking if you have other question later, you can ask
Yes.
it later. You mean this?
If we have some question in the process, what should we do? We should ask you or another person.
If you have some problem with the project, you can ask me in direct message. In the process, there are no problems about this. Have I
What's
answered
your
your question?
so
So
what's your
the
Let's start
project
again.
task,
Let's start again. I lost the question. Could you ask it a bit again?
I have a question.
Uh-huh.
Um,
So, what's the question?
what's your Telegram username?
Uh, I will send you. I will send you it's my Telegram name. I do not remember. A bit later in the chat group where you can connect with me.
Okay.
sorry, can we have the project task in English? The project task
Ah,
you listed.
you asking to translate this presentation in English?
Yeah, not all of it. The task you listed.
Yeah, no, sure, no problem. Sure, no problem. Sorry, I was a bit lazy to make English translation, and I forgot about this. I will do this after the election and double it in for your group.
Thank you.
Mm-hmm.
I am primarily from an electrical course of this. Yeah, can you hear me? A question, please.
Yeah.
A question that involves practical demonstration assistance. How do we go about it?
What kind of assistance?
Maybe for implementation of probably a program or a prototype or something like that.
You're asking about validation of prototyping of some kind of design of simulation model?
Yes, something like that. Something practical, not just maybe a written question, maybe something that needs a kind of practical direction or demonstration.
For this, firstly, you need to make simulation model to prove some kind of hypothesis. For example, you want to prove if some kind of mechanical design works or not. And before doing the prototype, which can fail, you firstly need to try its own simulation model. Here is Mojoko simulation model. And if you prove that it works somehow and moves as desired, you can make the prototype. But the key thing here, if the simulation model fails, you just need to rewrite a couple of strings of code to run another different design. But for prototyping, you need to redo entire thing again from zero. So this is the key thing of simulation model. And for some kind of and I think prototyping here doesn't match with the idea of the subject because the subject is related to simulation models. Prototyping is mostly related to experimental validation of some kind of idea, and it's mostly connected. I believe it's mostly connected for scientific research to when you have made some kind of scientific contribution and you want to prove that this contribution works in the real world. So here I think that most key thing for the subject is to make a simulation model, but not the prototype. But if you're interested with, and maybe if you want to work with this thing, and you can ask also Ivan Borisov, and we will talk about and we will discuss this.
All right.
Got it? Okay, I think maybe if you have any question, you can ask me a bit later. I think we can move from the themes of projects to entire pipeline of our subject. Actually, as you have noticed, we have very dense graphic of lections and practice tasks for the subject, which is not very good because as you can see, let me show you a scheduling of the subject. Here you can see that we have 2 lessons today, then 2 lessons in 1 week, and that's all. You won't have any practices, which I think is very bad, and actually it's wrong to make this scheduling with a lot of practice tasks in 1 day, because I think for today we need just 1 hour to cover all key things. And since the exam will be held, this subject will have the exam, and since the exam will be held about in December, maybe it's the late of December, as Ivan Borisov said, we have about almost 2 months for the subject, and I think we need to elongate the subject to for you to have more time to complete your practice and project. And here I claiming that you will have about 6 weeks to complete this subject. So not counting this ending week, you have 1 week, 2, 3, 4, 5, and 6 weeks. So the last week of the subject will be at the mid of December. So covering the last working day is 13th of Friday, very lucky date on December. So you have following 6 weeks to complete 4 practice tasks and 1 project. And here I have made folder, which I will share with you after this lesson, where you have all the supplementary materials to start. First of all, here is let me zoom it up. You will have records of the practice tasks and lessons. Here it's MP4, some lections and practice tasks. And then you have the folder of completed tasks where you need to upload your completed tasks. Here are 4 tasks, ATP of the project and the project itself. For these tasks, I have uploaded this blank file. This file doesn't have anything, that's just that's the example how you need to name your report. What you need to do, you need to make practice tasks, and after that, write the report in Word or in LaTeX, if you know how to use LaTeX, like, for example, in Overleaf. And in the reports, cover what you have done in the project, step by step, the name of the project, your name, blah, 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 and then the results of your work. And you need to name your report in the following example. Your ISO number, then your name, and then the name of the task. This file, as I said, it's just blank. It doesn't have anything. That's just example how you need to name it. For example, here my ISO, my name, and task 1. And the second folder, again, ISO, my name, and task 2, and so on up to task 4. Then you have 2 folders for the project. ATP means in English aims, targets, and plans. You need to make some kind of a description what kind of project you need to work with, you want to work with. And for that, you need to write this ATP. That's a small one, maybe at maximum 2 list file in PDF, where you need to write firstly your team, who is in your team, up to 3 people, maybe maximum 4 people, but better to be in 2 or 3 people team. What kind of project you want to work with, and what aims of the project you have, what targets of your project you have, and what are you planning to do with description of the deadlines of the task you need to do. Then you upload this ATP on this folder. Blank example is also here. Better actually to name it, or here place the name of all your group if you work with a lot of people, more people. And is this ATP file, you need to, as I said, write your names, name of the project, aims, target, and plans. And if your aims, target, and plans are not correct, we can reduce them and make a different step of planning the project. Because what's the idea of this file is for me to see what you're planning to do. If you're planning to do some kind of not very good work, maybe it's a bit too easy, I need to make you rewrite it to make it a bit more complicated, or vice versa. If your project is too big and ambitious, and for example 6 weeks is too small for this project, I will say that no, that's overkill. Make a bit easier task just to fit in the schedule. So that's the idea of this file. And after that, you start the project. And in the last folder, you upload your project reports, and then you need to define the project itself. For the tasks, you need just to upload the files. I will look at them, and if I do not have any question, I will cover the points for the project, for the completed project, because as you can see, there are a lot of people here. I can see 23 people on Zoom, and to to speak with each of you by person, it will be a lot of time, actually, unfortunately, because I understood that I need for you just to upload the file. I will look at them, and if I do not have any question about this, I will just make you this tasks covered. If I have some questions, some problems, I will write you in Telegram or in the mail. So you need to also provide some kind of contact info in your report. For the project, you need to defend it. I think the defenses will be in online format. We just will connect in specific date and discuss the results of your project. And also at each week we can connect for like half of an hour if you have some kind of questions, and we can discuss in online some questions of the tasks of the project. So do not worry, I will be with you all and for entire this project for this entire 1.5 months. So that's about the folder of complete tasks. Then the tasks itself, where I will upload the tasks. Here you can see just the first task. What the first task is, here you can see PDF file which covers the description in Russian and in English. The objective for the first task is, according to your variant, which 1 or 2, perform analytical and simulation model of one-dimensional system according to the variant. First variant has rotating pedal with spring and damper with some kind of initial angle deformation, because its normal state at the rest is vertical and you deflect at some kind of degree. Second variant is this cart with spring and damper, which deflected horizontally. And actually that's the same as vertical spring damper system, but without the gravity term, because let's say there are no friction and entire forces work only from stiffness and damper. And the objective here to compose the ordinary differential equation for the second order of the system. You can do this just by hand or use Lagrange second form. You need to compute Lagrangian and use some differentials. I think you know how to do this. One also have showed you in his lections. Then write the function according to example. Let me show elaboration of this in VS Code. What I mean by this. Here you will have the repository from GitHub. Ivan have shared it with you. They know SimRob's repository, and here you have all the examples you can work with to meet yourself with Majoko. At the right, I have opened VS Code with this repository, and at the lecture 1, there modular and simulation file. Here you can see the description of the file, how to do the model of dynamical system using this Lagrange equation of motion and all the stuff. And after that, you write the function of the system, how it's covered here. I would like to show it on my table, but unfortunately it's now powered down, so I will write it in Paint. So what's the key thing? You have the following equation of motion for mass spring damper system, which looks like this. It just damper spring, which deflects at this degree of freedom and has gravity term. And the equation is mx double dot plus bx dot plus kx, plus kx plus mg equals 0. And the idea here is to make the biggest derivative on the left and all other stuff to the right of the equation. So you need to place these guys to the right and divide by m. So the following equation will be like this: ax double dot equals minus 1 over m of bx dot plus kx plus G. So the function here is the same. The double derivative of x minus equals minus 1 over m times b derivative of x plus kx plus g. And you describe the here you have described the function of the 1D model. Then you use different types of solvers. Here we have you need to use 3 types of solvers: forward Euler, backward Euler, and Runge-Kutta form. Here as the example, one has written backward Euler, which uses algorithm. Also for my to understand it better, I have written my own function with Runge-Kutta form. You can copy it, but better to go into it by yourself to understand how it works. And to look how to make these models, there's some examples of integrator scripts by they are written on a different language. I forgot the name of the language. It's very like it's something between MATLAB and Python. Well, I remember it. It's named Julia. It's very similar to Python and it's very similar to MATLAB. It's somewhere between them. And for example, the function of forward Euler method, and you need to rewrite it into Python syntaxes. So the idea is to just rewrite it and use the solver. And key thing is to look how the position, speed, and acceleration of the spring damper system behaves over the time. You can model, for example, for 10 seconds, and look how different solvers act differently and make some kind of cover some kind of discussion of what solvers are better, what's worse, what is better to use, and so on. And well, as I said here, compare simulation results and draw conclusions. And last is write a report in PDF of the results of your work. And for supplementary, for more details, you can see lectures first and second on this following workshop is named CMU Optimal Control. Is a session of lessons, and I provide support and I advise you to look at these first 2 lessons. Lections. It's has written very good. It's very interesting. Me as a person who doesn't know absolutely nothing about control, understood a bit how to model these things. The lecturer describes forward and backward Euler, Runge-Kutta method, how they behave, which is better, which is worse, which the idea of optimal control in very brief examples with pendulum. And I advise you to look at these first 2 lectures. So that's for the first project, or for the first task. And here is a table in Google Sheets. You can see your names. They're written in here in Russian and in English. You have variant. You have your ISO number and parameters of spring damper system you need to place into your project. As an example, you can see they're just how these values are randomly generated, and here I have just baked the generated results, because if I change some number, if they were generated by formula, they will change completely. So these numbers only values. So for example, for this variant, you have a second variant, this ISO number, mass of the spring, a mass of the object is 0.8 kilos, stiffness is 11.6, dampen coefficient is this, length of the pendulum is this, if this is pendulum is this, initial deformation of the pendulum in radius is this, and initial deformation of the linear spring in meter is this. So as you can see, for the task For example, for second variant, theta is absent. So if you are, for example, second variant, you do not need to look at the parameters of theta and L because they do not work with you. But I have just copied the entire spreadsheet for all variants, so you need to look at by yourself what parameters to use or what not according to the variant. So that's the idea for the first task. Do you have any questions about this? All right. So if you don't have any questions, but if you will have them later, ask me in Telegram. So no problems here. And last but not least, let's discuss the deadlines. At the folder of the subject, the last spreadsheet is the entire list of all of you. First, we are going to the Russian team and then your English team. So you have your variants doubled here and your ISO numbers. I believe they have the same variants. Yep, they have the same variants. But here, that's a spreadsheet for me and for Ivan, where we placed the points for your completed tasks. What's the idea here? You have 4 practice tasks, ATP, and the project, and the exam at the end of the subject. Key thing is to make all the tasks and do the project. Only after that you will be submitted to do your exam. The deadline system for the projects to motivate you to complete the tasks as soon as possible. For the first task, maximum you will have is 15 points only if you pass, if you upload your report before 15th of November. So you have almost 2 weeks to do the project. So at the 2 weeks, the last working day, 15th of November, will be the deadline. And if you do your project after this deadline, you will have only 8 points instead of 15 for the task. For the second task, which I will give you later in the next weeks, the deadline will be 22nd of November, third task 29th of November, fourth task is 6th of December. If you postpone these deadlines, you will also have only 8 points instead of 15. Then for ATP, you need to make your team and upload the project ideas before 22nd of November. If you upload it later, but earlier than 29th of November, you will have only 4 points. Oh, sorry, I have made error. Max 5 points. If you make it from 22nd to 29th of November, 4 points. And if you made it later, 29th, you will have only 3 points. And for the project maximum, you will have 15 points. And following deadlines, if you postpone them, you will have, yeah, there's some kind of errors, like that's too low. Let's make 10 points and 8 points for the project. And for example, the maximum you can have is 20 points. So for example, let's say this person have made 15. He have made 4 tasks before the deadline, but for ATP he made it very late. He covered 3 points, and project is only 8 points, and exam he have written it a bit mediocre, so let's say 12 points. So he will have 83 points of 100, and here you can see the grade stable. 83 means this row, which means very good. So it will be 4, or in English system B. For example, he postponed all the deadlines to make a very mediocre result from 53, which will be less than a fail, so it will be unsatisfactory, and he will fail the subject. And not to fail, he needs to make the project before the deadline and to pass the exam a better grade. So the idea of the system, if you postpone the deadlines, you will be punished by lower grade. So that's about it. Do you have any question about the system or some other which I have told before?
I have a question.
Mm-hmm.
When we submit our tasks in the deadline, is there a possibility that we may take less than 15 according to the performance?
What do you mean?
Like
If
if
you
like if the report is not complete or something like this, we might take less than 15, right?
I mean, if I got the report. So if you uploaded your report before the deadline, but the report has some issues, some errors, and you
Yeah.
have actually that's not big issue. You just need to if the key thing is just to upload before the deadline. If you have some
Okay.
errors, you can redo them, but as soon as possible. And if you've done everything before the deadline and quite fast after my corrections, you will have the maximum point for the task.
Uh-huh. Understood.
Mhm. So, other questions?
I have a question about the results report. Do we need to like send a video of a simulation, or we can just send screenshots in the report?
Let me think. That's a good question, actually. If we have not a lot of teams, you can write. Actually, I think that we can do this following. You can do screenshots and upload them into the report, but at the defense, when you connect to some kind of chat, maybe Zoom on other online room, you need to show your results in online to me, what you have done. So you don't need to write any videos, you just need to make a screencast of your screen of the results of your work in simulation model. Got it?
But that's for the project. What about for the task or the
Tasks, you don't need screenshots for the task. Oh, yeah, sorry. You don't need any videos for the task. You just need to make the screenshots, upload into the report, and load it in the Google Docs, and I will check it by myself. So here it's not big deal. It's a lot easier than just project. You just need to practice for the task to perform to get better this performance in the Majoko. So you do not need any videos for this project, for this task.
Okay, thank you.
So, any questions?
You said that we will talk about how you accept our projects, our proposals.
Yep. You have a question about this, how it will be accepted?
Yeah, like you said, we can suggest project, and you said that you will
Yeah.
explain how we're gonna
Yeah, yeah,
accept
yeah,
them.
yeah, yeah, yeah. You need to cover your connection, how to say this, your link to your Telegram or to your mail in your report in your proposal. And if I have any questions, I will write to you at maybe at mail or maybe in Telegram direct message that I have some questions. So maybe you have some troubles, you need to make the project more harder or to ease it a bit. And if I don't have any questions, I will just say that, for example, you just look at the table, and if you have, for example, here 5, that means that I have accepted your proposal, and you can start your project. I will do my checks maybe every 2 days. So, for example, for approximation, if you uploaded it at the Monday and I look at it only at Wednesday, that's okay. But if I don't look at it more than 2 days, you can write me and direct messages to look as soon as possible. So because I won't look at the folder every day because I also have some kind of tasks different. And if I have some kind of disconnected from the folder, you can update me this information. And maybe if you have struggling with some kind with the task, you can just ask me Telegram directly before the uploading it to Google Docs, where we can discuss what you need to do, and after that you can upload the proposal.
I have a question for the table you showed us for task one. I don't know if you can open it again.
Was the question about this?
Yeah, you mentioned something about selecting variants according to our names. I didn't get that. I don't know if you could go over it.
Look, for the first task, you look at this table, and for example, what's your name? Could you say what's your name? We can find it on this table. For your personal example, I can describe this. I lost you. I cannot hear you. Okay, maybe you have some troubles with microphone. For example, you're number 13 from the English group. You look at your ISO number. So if it's correct, that's you. For example, first at the first column, as the column C, you have the first variant, which means that you have first variant as the practice task. Here you have the task of rotating pendulum. And here are the parameters you need to use in your model for the pendulum, like length of the pendulum, initial angle declination, mass of the body, stiffness of the spring, and damping coefficient of the damper. And then model hard code the parameters into your script in Python and look what solvers spit out, what's the theta position of the pendulum, what's theta dot, angular velocity of the pendulum, and theta double dot, angular acceleration of the pendulum. Compare three solvers with these three parameters, write a report, and that will task one. Got it? Okay, let's say you.
So we basically have to implement either of the two variants based on the table.
Based on table, yes, of course. If you have written first variant or second, you need to work only on the first or second table, first or second variant respectively.
Okay.
Got it. So, question in the chat. Could you please briefly explain how were to use the variant? Okay. I discussed this just now. All right. So, any questions?
Our project, we should write a piece of motivation. And
Some troubles with your microphone. I didn't understand what you said. You have told motivation with the project and what?
our project, when we want to describe what we want to do, we should write a piece of motivation and upload it in this platform, or we should something in
I have lost you again. Okay, I got it. What you mean? You need to write your proposal. What's the motivation? What your aims, target, and plans of the project? What's your team? Who is in your team? Your ISO numbers and your connection links for your mail or for your Telegram, and then upload this proposal in tasks. In completed tasks in ATP folder 5.atp. Upload here, write your ISO numbers, here write your name and ATP. After that, after I upload this, I will look at this and cover you if I have some questions. If I don't, if everything is okay, I will just put into your table in the table that's everything okay. You have, for example, 5 points if you have written this ATP before the deadline.
Sorry, sir. This folders will be sent to us.
What do you mean?
I mean, these folders that contains the task and all that. Would they be sent to us?
I have sent it to Telegram group right now. I will send it after the lesson. I will compose a letter, and you can go in all these links. I just showing how to work with them. So
Okay.
it's a bit later.
All right.
Mhm.
It's all right, sir. If I may get you very well, it means that we are going to do tax 1, tax 2, and tax 3 plus tax 4 on our own before we form the group.
Didn't get the question.
Okay, we are going to solve all the tax, 4 tax individually before we form the groups for the project. Should I come again?
You're asking, can you do the project only by yourself without the team?
No, the task.
Task. I got it. Tasks are made individually. Project is made in small group. So all of you need to do the task by yourselves. But the project you can work in a team where you can divide some sub tasks of the project to perform better. Got it?
It's all right. It's all right. So the formation of team for the project, are you going to do the formation or we are going to sort it out ourselves?
I have showed you some kind of motivation of the projects, which you can take inspiration from. But if you have another idea, you can do your own idea for the project. And ATP is needed for me to look, is this project okay, to make some kind of sanity check. Is this too easy or too hard, or maybe if it's good for deadlines, because we have not a lot of time for the project.
It's all right, but it seems you haven't gotten my question right.
Yeah, possibly.
I say like formation of team members for the project.
Mm-hmm.
Are we to form the team ourselves, or you are going to
Yeah,
form the team? We are going
I
to.
got it. What you mean. Yes, of course, you need to do this by yourself because I do not know who you're in friendship with. Maybe you want to work by yourself, or maybe you want to ask some guys who they are to work with. Because I do not want to force you to work with some kind of people because maybe you're not in a good state with yourselves. Maybe you want to work with different person, and that's up to you. You need to form it by yourself. So you have some spare time to start this networking, and after that, you can start writing ATP.
It's all right, but can you decide to do it on your own?
Actually, I think I do not have some kind of permission to control you because you are free people and you can do as you wish. You can ask some guys. If the view, actually, if you have some connection problems and with other people, if you do not know how to connect with, some of you can write me so that you cannot start a team. And if I collect some number of people, I can gather you together with one or two teams of people who haven't founded the people. And after that, you can start making the ATP. So maybe you
It's
can
all right. Thank you
actually.
very much.
So actually, if you have, besides you, if you all have some kind of this troubles, you can write me in direct message that you do not know how to connect with, and after that, after some time, couple of weeks, I will propose for some of you to connect in the team. Okay. Any other questions? All right, so let's say that right now you do not have more questions. If you have them later, you can write me in Telegram again. And for this, I think we can finish for today. We do not need the second hour because that's all I want to discuss here. I will update the presentation in English. I will update the links. I will send the presentation, the folder in the message in the subject in the group chat. And after that, you can start. I will do it right now, maybe in half an hour, maybe an hour. I will share the links and the time. I will write the message. So I think I can stop here.